So hello Year 10s, and as you know we're looking at conservation of mass and whether or not reactions appear to gain or lose mass. So the first reaction here, what we've got is we've got a balance that is almost perfectly balanced with some iron wool in the container on the right hand side. And the first thing we're going to do is we're going to set fire to that iron wool and see what happens. What do you think is going to happen to this balance? Okay, and you can see here we've got the iron wool that Miss Richardson is about to light. Okay, cool. And if we just watch that now, as that iron wool burns. It's burning nicely. Still burning.
Yeah, still going.
Still going. Is this going to work? Have I set this up correctly? There we go.
And it's moving.
And there we go. So we've got the iron wool gaining mass as it burns. Was that what you expected? Many Year 10 students are surprised by that observation. Can you explain why the iron got heavier as it burnt? Okay, moving on to the next reaction. We have here some potassium iodide and some lead nitrate. So let's zero the balance, Miss Richardson.
Lovely.
Excellent. Zero there. Yeah, about 50 ml of potassium iodide in that. And if you could stick that and the lead nitrate bottle on the balance, and we'll see what the mass is. Okay. Total mass 197.26 grams. And now a few generous squirts of the lead nitrate into that. Now, lead nitrate is, of course, deeply poisonous. You can see the poisonous symbol on there. And here we go. 197.24. That's slightly off, isn't it, sir? But actually showing that we've got this beautiful colour change by reacting those two things together, and virtually no change in mass. Finally, we've got a lovely reaction here, which is very, very strange. It's an odd reaction that we go into in a lot more detail. And the first thing Mr. Reeves is going to do is he's wetting a wooden block here. That's going to go on the balance. And then if you stick the two beakers onto the wood as well, just so we can weigh them.
I've kept the glass rod.
Yeah. 196.68. Okay. Now here's the weird thing. We're going to mix those two solids together, and then Miss Richardson's going to give them a good stir and then put them back on the wood. So mixing them together. Now this is a really odd reaction for three reasons, one of which is it is a solid reaction. So you don't get many of those where actually the reaction occurs between two solids, or normally you need one of the reactants to be at least in a liquid or a gas. Now, what are you smelling there, Miss Richardson?
I'm smelling ammonia, which is quite a strong smell. It gets to the back of your throat.
Yeah.
And this is very cold.
Yeah, it's getting very, very, very cold here. So that's the second thing that's weird about this.
You can see it's starting to form a paste.
So forming a nice paste. Oh, it really reeks, stinks very, very much here now.
And now it's much more liquidy.
Yeah.
Very, very cold to the touch.
It's gone all liquid, not because it's melted, because it's gone the other way round. It's actually got cold. So let's have a look at what's going on here. We'll speed this up in post-production.
Shall I scrape the excess off the glass?
I guess in a fume hood this works quite well, doesn't it? Because it's evacuating the ammonia. Cool, so we can definitely see the reaction losing mass there. As Miss Richardson said, these two solids have turned into a paste. And now, do you reckon that's long enough, Mr. Reeves? We'll see if we take off that and we try lifting the other beaker, what happens, Miss Richardson? There you go. It's cold enough to have frozen the beaker to the wooden block.
It's really cold.
It is well under 0 degrees now, and so that is a reaction. Not only has two solids reacted together to form a liquid, not only has it got cold, but it has also lost mass. Thank you very much, Miss Richardson and Mr. Reeves.